Okay, grade 11 learners. Welcome back to the second learning episode in Earth Science. So the physical and chemical properties of minerals. Let's start with the chemical properties of minerals. So they show the presence and the arrangement of atoms in minerals. So using their chemical properties, minerals are identified by how they react to certain substances. That's why we call it chemical properties. The first example is the silicate class. So it's the largest of minerals, and they contain silicon, oxygen with some aluminum, magnesium, iron, and calcium. So the common examples are olivine, pyroxene, amphibole, muscovite, and feldspar. So these are the uses, like the microchips that are used, and then something in men's watches. Next is the carbonate class. So the carbonate class refers to the deposited in marine environment, so like in shells of dead planktons, places with high evaporation rates, in carts and caves, and in stalactites and stalagmites, also in caves. So the common examples are the aragonite, calcite, malachite, and aragonite. So the uses are the carbon paper that we have, the glass and ceramics, the rayon, the soap and detergent, livestock mineral, and soda ash. So these are examples of carbonate class. The third class is the sulfate. So it is where salty water slowly evaporate, and then you can also find them in places with high evaporation rates and also in water sediment. So the common examples are the barite, the gypsum, and the silicite. And their uses are the plaster, the mineral supplement, the Epsom salt, the surfactant, and also lead acid battery. Halide class is very common because they are the ones that contains natural salts. So they are found in lakes, ponds, and other landlocked seas. And the common examples are the halide and the fluoride, and these are the images that you can see. And the uses are the metal halide lamps, steel and aluminum, fertilizer, and the common rock salt that we use. Next is the oxide class. So the oxide class is the most important class to human civilization. Why? Because they carry history of changes in Earth's magnetic field, and it's also referring to the precipitates close to Earth's surface, oxidation products using weathering, and then accessory minerals in igneous rocks. So the common examples are the hematite and the corundum. Not so familiar, but their uses are very familiar to us. So like inorganic sunscreen, the flame retardant, the coloring agents, and the alkali batteries are common in oxide. Then the sulfide class, which is the sixth group, they contain the most of the economically significant mineral to man. So it includes copper, the lead, and the zinc. So common examples are these images, the acanthite and the chalcocite. So the uses are the photocells that we use, the fungicide, the infrared sensors, photoluminescent strips in emergency lights. So those are the sulfide classes. Then the phosphate class, important to biological minerals. They're found in bones and teeth of animals, the phosphorus that is in there. And then the common examples, the turquoise, the wavelight, and the apatite. Now uses are phosphate fertilizers used in the farm, then the health nutrients, and phosphate salt, so anything that contains this phosphorus. So the next property of mineral that we have to tackle with is the physical properties. So when we talk about the physical properties, commonly we refer also to the color. So the color is easy to see, but is the least reliable property for ID of certain mineral, because many different minerals are same color, but they are different in classifications. Same mineral can come in many colors, like the quartz can be pink, white, clear, purple, and yellow. So one mineral has different colors, so it's really different, and it's very difficult to identify. Then the luster effect. So the mineral shines when reflected to light. So we call it luster. So when you say metallic, they're like polished metal, and non-metallic, all others like glassy, pearly, and dull color. So they are non-metallic mineral. Next is the streak. Color of powdered form of mineral. So not always same color as mineral. They're found by rubbing mineral on unglazed tile, and non-metallic mineral usually have white streak. So when you are going to rub it, it will produce white streak. So that is non-metallic. Next is the cleavage. So mineral splits along flat surfaces. So it can cleave into one or two or three directions. So like here in the examples. So these are the cleavages. And we have here some more examples of this physical property of the cleavage. Next is the fracture. So minerals break along non-cleavage surfaces. So it's not the cleavage surface, but it breaks. So they are considered as the rough edges. As time goes by, they break, and they form this fracture. So they form rough edges. And then conchoidal fracture, the smoothly curved like inside of a shell. Now, the most important physical characteristic of mineral is the hardness, because we refer to the most scale of hardness in order for us to determine how hard or soft the mineral is. So minerals' resistance to being scratched, referring to hardness. So we have here the most scale of hardness, which is number 1, the talc, and the softest is the talc. The second one, gypsum, the calcite, the fluorite, apatite, feldspar quartz, topaz, corundum, or the ruby, and the diamond. So the diamond is the hardest of all. So in most scale of hardness, we can also check using some tools in order for us to know whether a mineral is soft or hard. So the fingernail can be able to scratch mineral under the category number 2, and the penny can be used also to scratch mineral under category number 3, steel nail for 4, and for the harder one, the mineral scratches glass for category under number 6. Next is the specific gravity of a certain mineral. It's also one of the physical characteristics. So it's referring to the dense of the mineral. Okay, metallic usually is less than 5, and then metallic is usually metallic is usually greater than 5, and non-metallic usually is less than 5. So these are the specific gravity, metallic and non-metallic in the image. Now, acid test is also referring to the physical characteristic of minerals. So only carbonate minerals feeds in weak acid. Okay, so like the calcite, so when you put acid on it, so it feeds. Meaning to say, it reacts. In number 9, crystals. Not all minerals show crystals. When minerals do show crystals, they usually have a characteristic shape. Okay, so remember, not all minerals will show crystals. So some will not. And the last one is the special properties. Okay, other properties like the taste, the rock salt, you can taste it. The smell of the sulfur is very strong. And the fluorescence, it glows in UV light. So we know that it's fluorescence. And then radioactivity of uranium, and double refraction to images show through clear mineral, which is referring to the calcite. So with these some special properties, they are easily identified, okay, using the taste, smell, and then glowing, and then the radioactivity, and some others. There are 3 classifications of rocks. The first one is igneous rock. So igneous comes from the term ignis, a Latin term which means fire. And igneous rocks are formed from the cooling of either the magma or the lava. And they are the most abundant type of rock here on Earth. So they are classified according to their origin. So where they are formed, like for example, number one, intrusive. So intrusive are formed below or underneath the ground. Okay, and usually they have large crystals because they are formed for a long period of time. Okay, so that's why the crystals are growing, and then they are very visible in this type of rock. The next one is extrusive. So extrusive, from the term itself, they are formed above the ground. So it is formed when the lava is already exposed to the air and it hardens. So it forms an extrusive rock. So usually they have small or no crystals at all because they harden so quickly when they are exposed to the air. Okay, when the lava is exposed to the air, naturally it hardens quickly. So they form only small crystals and sometimes no crystals. Next one is sedimentary rocks. So from the word sedimentary, okay, they're formed from sediments, or let's say the rocks, fragments, the mineral grains, and the animal plant remains composition. So they are like the accumulation of these different types of formations that are pressed or cemented together, or when sediments precipitate out of a solution. So usually sedimentary rocks are very, very significant when we are also studying the history, because over time sedimentary rocks form layers, and these layers will signify to which organisms present in each era. So there are three types of sedimentary rocks. The first one is chemical sedimentary. Minerals dissolved in lakes, the seas, or underground water. So they form chemical sedimentary rocks. The next one is the limestone. The examples are the limestone made when calcite mineral precipitates from the sea or water. And another example is the rock salt made from the evaporation of the another type of sedimentary rock is the clastic sedimentary rock. It's also called as detrital. Okay, that's the other term, and made from broken pieces of other rocks. So when other rocks break down due to some factors, okay, like erosion, landslide, and so on, when they're exposed to rain, so they sometimes break, and then they're carried along with the water, and then they form into another rock. Okay, they are accumulated into one place, and they form and they harden and become a rock. So that's clastic. Okay, the different pieces of rocks are joined together. The next one is the organic rocks, or they are the hardened remains of plants and animals deposited in thick layers. Examples are the fossils rich limestone made from the shells of the ocean animals. And the last classification is the metamorphic rocks. So they are rocks that have changed to intense temperature and pressure. So over time, when rocks actually change in their component, let's say their formation and their physical characteristics. So when igneous and sedimentary and other metamorphic rocks can change to become metamorphic rocks. So igneous and also sedimentary. So how are metamorphic rocks classified? Okay, how do we know that they are metamorphic rocks? So some metamorphic rocks are classified into foliated. Mineral grains are flattened and lined up in parallel bands, so foliated. And examples are the gneiss, formed from the arrangement of minerals in arenate. Okay, and then another is non-foliated, so no bands are formed. So example is the marble. Yeah, you don't see lines in there, so it's non-foliated, and that is also metamorphic rock. Once again, this is your teacher in grade 11 Earth Science, leaving you this quote of the day. Rocks are hard as anything, but the water still overcomes it. So if we represent these rocks to our problems in life, no matter how hard and difficult they are, still there is always a way to overcome them. With perseverance, hard work, and prayer, we can all overcome the difficulties in life. So, I'll see you all in our next learning episode. Thank you for watching and have a good day, everyone.